Welcome back to my channel. We're going to be talking about definite integrals and all the different theorems that go along with definite integrals. So we're going to start with what a definite integral is. It's a integral that is over a specific bound. The first one we're going to talk about is FTC number 1, the fundamental theorem of calculus number 1. Depending on what book you're looking at will tell you if this is actually FTC number 1 or not. We apparently can't make up our mind as a community. So here's what you need to know. If a function f is continuous on the closed interval from a to b, capital F is the antiderivative of lowercase f on a to b. Then, so what they're saying is if we have the integral from a to b of f of x dx, this is the same thing as the antiderivative of that function on the interval a to b. Well, we also know that when we're looking at an interval, we take the second point and subtract it from the first point, and that gives us that interval, which is where we get f of b minus f of a. So if I have an integral from a to b on a specific amount, we're looking at the antiderivative, plugging those values in, and going from there. So we're going to look at this problem here, the integral from 2 to 5 of 2x plus 7. So the first thing we do, integrate. So the integral of 2x is x squared. The integral of 7 is 7x. And we're going to evaluate that on the interval of 2 to 5. So now we need to plug in the top number 5 first. So I have 5 squared plus 7 times 5. And I've put it in parentheses just to kind of make sure that I don't simplify something later. And we're going to subtract when I plug in 2 for everything. So I have 2 squared plus 7 times 2. So when I'm looking at that here, if I simplify this, 5 squared plus 7 times 5 happens to be 60. 2 squared plus 7 times 2 happens to be 18. So I have 60 minus 18, which is going to give us 42. Now we're going to look at it the other way around. And what I mean by the other way around, I mean let's flip the interval and see what happens. So thankfully we already know that this integral is x squared plus 7x. And we're evaluating it on 5 to 2. So now we're looking at the 2 being on the top. We always do the top number minus the bottom number. So that means we have 2 squared plus 7 times 2 minus 5 squared plus 7 times 5. We already know what those two things equal individually. We have 18 and 60 because they are the same things. The difference is that they're flipped. So we get negative 42. So one of the things that this tells us is that the interval, if we flip it, is going to flip the sign of our answer. So the integral from a to b of f of x dx is the same as if I were to take the integral from b to a of f of x dx and then change the sign. One thing to also note here is that we don't need our plus c anymore. The reason being, if I were to add in this plus c, so do x squared plus 7x plus c from 2 to 5, and plug that in, 5 squared plus 7x, 7 times 5, plus c minus 2 squared plus 7 times 2 plus c. And then if I were to simplify this, I get the 60 like I had before, the 18 like I had before. You may notice that I kept the parentheses on that second one, and it's because we have subtraction, so I need to distribute that subtraction. So I have 60 plus c minus 18 minus c. We have a positive c, we have a negative c, so those are going to cancel each other out. So we end up with 60 minus 18 to give us that 42 still. So the reason why we need to get rid of that plus c is because we're adding a constant to both terms, and because I'm subtracting them, I'm subtracting that constant from each. So they end up canceling each other out. So even if we don't know what that constant is, we don't necessarily need it with a definite integral specifically. If it's an indefinite integral, then I just need that c.